days work on PA4 if you have a group? Do you only get to spend one person's slip days?
Oh, that's a really good question. I hadn't thought about that. So I think if you spend a slip day, everybody in the group spends a slip day. And I would say if anybody in the group has slip days left, you can take them. If everyone in the group is out of slip days, then you can't do a slip day. But if at least one person in the group has a slip day, then everybody can use a slip day to turn it in a day late, and same with 2 days and so on.
I have all 4 of mine still, but
Okay.
I don't think my group mates, or at least one of my group mates, has spent 1 or 2 of them.
Yeah, if you've got all 4, your group could take up to 4 slip days.
All right, cool.
Yeah.
Thank you.
It's a good question. I should probably post an announcement on that because I haven't done slip days before this year, so this is a new approach for me. I've lost my Bluetooth too, but I think I can live without that for now.
You said if we don't use our slip days, they get converted to high fives at the end, right?
Exactly.
Damn it, I should have saved them.
Yeah, right. You can get high fives anyway. All right. Yeah, I'll post something to Canvas probably later today just to clarify that. I mean, we're kind of at the end. We got PA4 and PA5, so I'm not sort of anticipating a lot of issues around this. I think everybody's anxious to get done with school at this point, so sooner assignments get done, the quicker you can move on. Let's see, how can I change player after mouse was clicked? So tracking the player, you can have a Boolean variable or an integer or something, some kind of flag that indicates whose turn it is. Initialize it to whatever state means player 1. And then basically, in your mouse handler, you're going to do the following steps. So let's say you get a mouse click. I'm writing on this and you're not seeing it because my camera is frozen. So let me reset that. Document can. Let me change this. There we go, mouse click. All right, so mouse click, you're going to do the following things. Find the XY coordinates of the mouse click. That just comes from your argument. Find what box that corresponds to and what edge it corresponds to. Make sure it's not already clicked, not already drawn. Assuming that line hasn't been drawn, set the flag equal to true. Set line in adjacent box. So unless you're at the edge of your boxes, look in the adjacent box and set that corresponding flag to be true. See if box or boxes has been completed. If that line completes a box, right, add the initial. Increment the score, or maybe your score is just being incremented by the number of boxes and so on. If the box has not been completed, then you want to change whose turn it is. So toggle your Boolean flag, or if it's an integer 1 or 2, subtract it from 3 or something, right?
So real quick, while we're at the score part, so what I did was I had it run a method at this point to clear the score completely, go back through and count all the boxes, and it seemed to work very good that way, because when I was incrementing the score, for some reason it would add extra numbers, or like it was just kind of weird. So
Yeah.
I found it easier to reinitialize everything to 0, go through and count, and that way when you reset it, it just sets it back to 0.
Yeah, that's the way I would prefer to do it also. Instead of having a variable called score, or P1 score, P2 score, just let the board be the source of the score information and write a method that goes through the array of boxes and counts how many belong to each player and generate the score on the fly like that. And this way, if completing a line, if drawing a line completes 2 boxes, you don't have to do an extra, add an extra 2 to the score instead of 1. Just complete the boxes, right, and let the score method notice how many boxes belong to each player, and then generate the score from there.
That's what was giving me problems.
Yeah.
I was trying to do the 2 boxes because there was a lot of if statements. And sometimes it worked, sometimes it didn't.
Right. Yeah. So that's a good solution. Is make it a method. I'm still thinking, ooh, we got rain coming. That's awesome. Maybe hail. We're back to hail season. Cool. So something like this in response to the mouse click, and it's up to you whether you want to put this all inside that method, that gets created when you say add an event handler. You can put it all inside that method, or, you could simply get the XY and then call some method that you write called, respond to mouse click, and feed it those XY coordinates and have that method do all of this stuff. That's going to work really well for PA5, which we'll get to in a little bit. But, the goal is these are the steps that happen in response to a mouse click. How you make that happen is up to you.
And I got a quick question too, just on the layout. So I used a lot of global variables for the class, mostly private. But is there a preference that you would recommend passing the parameters to the method as opposed to using globals, or does it really not matter because those are members?
It doesn't matter too much.
Yeah, member variables.
So here's the thing with classes in object-oriented languages. So let's say we have, like a class rectangle, and we're going to have, an area method, which returns height times width. So in C, we rally against globals. We call them evil and such. And we say, don't use global variables. If you want something to perform a value on a variable, pass that variable to a function, right? And that's good advice in C. But in Java, it kind of looks a little different because, for example, there's an area method, right? And if we have a rectangle named R that we've constructed somewhere, and we want to find its area, we don't want to say, area parentheses R, right? That's a C version of how we would call a function. What we want to do is we want to say, here's the object, let's call its area method. And we don't specify the height and width as arguments here, right? We rely on the fact that inside this rectangle class, there's a pair of integers, h and w. Now these kind of look like globals inside this class. Any method inside here that talks about h, it's going to access this integer, unless it's been, redefined. W is always going to access this. So it's global inside the class, but it kind of has to be global inside the class because, these might be private. In which case, if we want to find the area of rectangle R, we don't have access to the height and width. And we can't define the height and width inside this method because then when we call the perimeter method, it doesn't have access to that h and w. So they have to be global inside the class. But one of the things objects are doing for us is they're letting us make, sort of these collections of global variables that are global within this definition. And they're global only within the scope of the things that care about those variables. So we can have an area and a perimeter and a constructor and a toString and so on, and all of those things potentially need to use the height and the width. That's totally fine. So in PA4, it will probably feel like you have a number of global variables, maybe the score and the player names and the turn variable and so on and so forth. That's usually fine, right? It's oftentimes the only way that you can do this, if that makes sense.
Yeah, that does. Thank you.
Okay, cool.
Some languages force you to use this and self and so on and so forth, like TypeScript and Python.
Mm-hmm.
Sometimes it's easier to distinguish your members that way.
Right, right.
But they're not globals, you know.
And I could always say this .h, this .w in Java to indicate that it's these variables up here. But most of the time, those are the variables we mean, unless we have local variables, and our local variables usually have different names from these sort of globals.
One of the things I like about this language is it's purely optional to use this if you name things correctly.
Mm-hmm. Right, right. All right. If you have the name of a player, so suppose you've got a string name, and maybe this comes from a text field or something. How do you get the first letter of it? Well, there's a method inside the string class called character at. And so if you say name.character at parentheses 0, that'll give you the first initial. And that actually comes to you as a character. And so it's a single letter, and it's like, you know, putting a symbol inside single quotes. If you wanted to have a string corresponding to the first initial, you could do something like this: name.character at 0, and then append an empty string, and that'll force this to be turned into a string. And so now you've got an actual string containing just that first initial. So that gives you a string with the initial. So you could do something like that. And then what do you want to do with that initial? Well, you need to use it when you find a box has been claimed by someone. So after you've done the mouse click and found the edges and so on, see if the box has been completed. Inside the box class, you might have a character or you might have a string for the initial. So you need to somehow access that. Well, when you get the XY coordinates of the mouse click, when I say get box, you're calculating the row and the column corresponding to that. And then it's just board bracket R bracket C dot box dot initial equals, you know, that stuff, or initial. Cool.
You could do the double quotes before too, right? Shouldn't matter.
Yeah, you could do double quote plus. And I think there's probably something in the character class that'll let you convert to a string. I think when I did this, I just left it as a character, because I think I was just using it inside the box class. But if you're going to use draw string, I think you have to pass a string to that.
Yeah, that was the problem I had. Was I had it as a character at first, but I couldn't find a method to draw the character.
Ah, okay.
So I had to convert to string for that.
Right. And there's other approaches. So you can do a substring. Substrings are a path to happiness. So you can do string.substring, and you could say 0, 0, and I think that'll return the first character exactly as a string.
I tried that actually. It gave me an issue.
What
but
sort
I
of?
think I only gave it the first part of the index. I don't think I used the second one there.
So if you use one index, that just tells it where to begin.
Yeah.
And so it takes a string from that point to the end. One detail to watch out for is if it was possible for your name to be empty, this will throw an exception. So if you try to do this and you didn't check to make sure that the name was not empty, this would throw an exception. So you may want to do something first, like if name.length is equal to 0, yell at the user. And don't do the character at 0, because an empty string there is no character at 0, and that'll blow up. I'm not likely to try to make your code break like that, but you never know.
Pretty funny to try though.
Yeah. Although not after like 30 or 40 programs.
Right. Yeah, you're gonna have a lot of fun this weekend.
I am actually. I enjoy playing dots, so it's always good.
It's probably more fun to play with other people though.
It would be, yeah.
So, quick question. This is probably more for PA5. You said we're going to be doing like an online version of the game.
Yeah.
How are you going to test that? You're just going to set up 2 computers and just...
I'll actually run both instances on one machine, and just change which window I'm clicking in.
Gotcha.
Yeah. But the way that you code it to make that happen is identical whether both instances are on one machine or they're on opposite sides of the planet. The code is going to work the same, which is pretty cool.
It is cool.
All right, good stuff. Other questions? All right, let's talk about synchronization of threads in Java. And so we talked on Tuesday about this idea of having multiple threads. So here's one thread executing, here's another thread executing, and so on. And if they're working completely independently of each other, usually no problem, right? Just construct a thread, call the start method, it makes a thread and runs the run method. But if these threads are interacting with each other, we can get into kind of weird behaviors. And we did an example with 2 ATMs connected to a bank, and saw how shared access to a resource can cause unexpected results. And we talked about some things like deadlock and live lock and resource starvation and so on that can happen again when there's shared access to a resource, and if we don't manage it correctly, or if we're very unlucky, things can get weird quickly. No, that is a good Java model, actually. So let's look at some code that illustrates some of the problems we can run into with threads, and then we'll look at the mechanisms available for dealing with that. So I'm going to show you some code for a fictitious voting system where we have a series of voting machines where people can cast ballots, and the votes are recorded in a central location that tallies how many total votes each candidate has gotten. So I have 2 classes in this project. The first one is called sleep class. It's just a wrapper around this static sleep method inside thread. But you got to wrap it in a try-catch block, so it's kind of a pain. So I have a method in here called delay. I can tell it how many milliseconds I want to delay, and this will just sleep for that many milliseconds. So that's just a way to kind of pause the execution of a program. So the more interesting class is votertest.java. And so this is a voting machine demonstration. So here's the setup. There's a central vote recorder. That's a class called vote recorder. And then I can create however many voting machines I want, VM1, VM2, VM3. Each of those voting machines I construct with 2 pieces of information: an identifier, so I can tell apart, one machine from another, and I also pass that constructor this central vote recorder, so that each of these machines can use the vote recorder to say, hey, we got 1 vote here, we got 1 vote there. All right, and this code is hardwired for a particular election. In this case, it's a runoff election between Darth Vader and Yoda. Okay, and they're vying for city commissioner of Vancouver or Emperor of the Galaxy. I don't remember which. And so we have an integer number of votes for Darth Vader and Yoda. In the constructor, we initialize them both to 0, just to be fair, right? And so we have some accessors and mutators, right? So if we want to know Darth Vader's count, we can say get Darth Vader. If we want to know Yoda's count, we can say get Yoda. And then we can set these by saying set Darth Vader or Yoda and pass it an integer n. And then there's the show votes method that just kind of shows the current tally so that we can put this on TV sets and people can watch the election as it's going on. And it's very entertaining. All right, so that's the vote recorder class. The voting machines, I've hardwired for what we expect the typical voting experience to be. So this is a simulation. So I'm going to construct again with an ID, which I'll save in this variable ID, and a vote recorder, which I'll save in VR. So I've got those two pieces of information stored. And in the run method, right, we're going to do the following. First, we're going to iterate 150 times as people cast votes for Yoda, and all of Yoda's followers cast their votes first, right? They get up first thing in the morning and they go and they vote. So what does a vote for Yoda look like? Well, you call the vote recorders get Yoda to find the current number of votes. You add 1 to that, and then you set it back in. And just for kicks, I've added a random delay in the voting process so that, these voters can like center themselves and all that kind of stuff. So they read the current number of votes, add 1, write the number of votes back. And then we'll go ahead and we'll show what the vote total is. So we'll see this as it accumulates. So 150 times people come in and they cast votes for Yoda. And then later on in the day, Darth Vader's supporters kind of get out of bed and they go to the polls, and there's 100 of them per district. And so they show up, they get the current total for Darth, add 1 to it, set that back in to the vote recorder, and then they show the number of votes. And this random delay is just waiting anywhere from 0 to 5 milliseconds using that sleep class method. All right, so that's the whole setup. And to run this the first time, I'm going to construct 3 voting machines, and I'm going to call each of their run methods. And this is not creating threads, right? This is just first I'm going to do vm1.run, which will simulate, that first district's voting. And then I'll do vm2.run, vm3.run. And so this will do pretty much what we would expect. So what happened here, right? Kind of the expected behavior. So when voting started, first we saw 150 votes come in for Yoda. And then Darth Vader's supporters showed up and they cast 100 votes for Darth Vader. And that was the end of Voting Machine 1's simulation. And then Voting Machine 2 kicked in. We got another 150 for Yoda. So Yoda got up to 300, and then Darth Vader's votes came in and brought that count up to 200. And then Voting Machine 3 opened, and 150 votes for Yoda, 100 for Darth Vader. So the final tally, Darth Vader 300, Yoda 450, and Yoda gets to be city commissioner. So that's exactly what we would expect to have happen, right? There's no funny business going on here. So I'm going to make one change to this code. And the change is, instead of calling the run method, I'm going to call the start method. And remember, when I say vm1.start, 2 things happen. A new thread is created, and then in that new thread, the run method is called. So vm1.start is going to create a thread, start executing the run method, and shortly after that happens, VM2 is going to start its run method in a new thread, and shortly after that, a third thread will be created to execute the run method in VM3. And we wouldn't expect this to change anything, right? The order in which people vote doesn't matter. It's still 150 times 3 is 450 for Yoda, 100 times 3 is 300 for Darth. So we expect the totals to end up the same at the end. So what happens when we actually run the voting? Guess what? Bad news. Right? Darth Vader is our new city commissioner. So those new parks we were going to get? Nope, not going to happen. Right?
Too many parking lots.
Yeah. So this is weird, right? And if I run this again, well, this time Yoda only got 151 votes. He actually lost an extra vote. And there's 163. So the behavior of this is unpredictable, but sort of predictably incorrect, right? The count for Yoda is nowhere near the 450 that it should be. So what's happening here is the thing that we were talking about Tuesday with ATMs and banks and atomic operations. So in particular, when people are voting for Yoda, there's a read where the current vote total is accessed. There's a modify where we add 1, and there's a write where we store it back in to the recorder. And this operation is not atomic, right? While these things are happening, another thread can be doing pretty much anything. And by adding this random delay in here, I've extended the amount of time this read, modify, write takes. And I did that deliberately to show you that I did that deliberately to kind of ensure that while this is happening, while these 4 statements are being executed, other things will happen simultaneously. And those other things are, sometimes interfering with this simple set of code, right? I mean, read, add 1, and write seems pretty straightforward. But the issue here, like with the bank example, is that, we read the current total, we add 1 to it, so now we have a vote total we're about to save, and if in between here and the next statement somebody casts 1,000 votes for Yoda, those are going to get lost, because we're going to take this variable, which was, 1 more than the previous vote, and we're going to write that back into the vote recorder. And those extra votes that came in during this time have been lost. Now, if I take out this delay, right, the delay is in there deliberately to mess things up. Right, things look pretty good. It's 300 to 450. But that's just luck. So let me go up here and let me just add a few more voting machines. So we'll have 6 threads this time. And so it should end up being 600 for Darth Vader, 900 for Yoda. And in this one case, Yoda ended up with only 899 votes. And if I was writing this code and I was testing it, I probably would have given up a few tests ago and said, yeah, this works great. And you put it out there in the field, and guess what? There's a bug in there. And it doesn't show up very often, and if this was actually a voting system and things are off by 1 vote, probably nobody would ever notice. Because, how do you know what the right vote should be? But, if something else happens, if there's a delay in one part of the code, if this one machine gets bogged down, if it loses network connectivity and it has to pause during its update, you might end up with these really bizarre results. So threaded code is tricky, right? Anytime you have multiple things happening, you kind of have to think at a different level in terms of what could happen, because you have to sort of imagine all possible situations of different things happening at different times, and that's just really hard to do. So let me put this back to this shorter example that breaks more visibly, and let's see how we can resolve this this issue. It's a problem if you like Yoda, it's a feature if you like Darth. Alright, so we've got our problem here again. So here's the issue, right? The issue is this operation is non-atomic, right? It can be interrupted. So there's a keyword in Java called synchronized. Or synchronize. And it takes an argument of sorts, which is a flag. I think it's synchronized. We'll find out when I compile. Synchronized parentheses, and it takes some sort of flag, and then curly brackets. And the deal is, everything inside here has the following property. If two different threads tried to execute this block of code, only one of them is going to be able to do it at a time. So thread 1 is going along and it gets to this statement. The JVM, the virtual machine, will check to see if anybody else is executing this block of code. And if not, it will do two things. One, it will let that thread begin executing these instructions. And two, it will use this flag to record the fact that somebody is executing this code. And now if another thread comes along and tries to enter this block, the virtual machine will check this flag and say, wait, somebody's already in here, you're going to have to wait. So yeah, this is a lock or a mutex or a semaphore. Goes under a lot of different names. There's slight differences between what those things mean. But it's basically a way to ensure that only one thread is executing a set of code at one time.
So it can definitely do more than like two different, because you said two different threads, so.
Yeah, so you could have 100 threads and they could all have this same block of code, and only one of those threads will execute this at a time. And all the others that are trying to do it will have to wait. And then once the thread that's executing this leaves this block, that flag is freed up and the JVM will give it to somebody else. Which thread gets the flag next, I don't know. It's a decision that's made by the Java virtual machine. But presumably it does it in a way that you don't have, one thread that's starved and never gets access. So it's probably keeping some kind of queue based on when threads hit this and block, so that it grants the access in turn.
Is there any difference between a mutex and a semaphore?
Yes, but I will let you wait on that question until you get to CS360 next year, because that will be a long discussion, I believe. Yeah, there's subtle differences, and you can read about them in the manual pages for Unix. And it kind of changes over time, sort of what people decide you should be doing. Like, you should be using semaphores, or you should be using mutexes because semaphores are buggy, or semaphores are better than mutexes because of this. So yeah, there is a difference, but we're not going to worry about it here. So we'll just think of this as a flag, right? In the sense of holding a flag up saying, hey, the railroad tracks are in use, don't come onto this line until I put my flag down. That kind of thing. And so that's the etymology, I think, of semaphore, was from rail lines. All right, so this flag can be any object that we want, right? But it's got to be the same flag in each thread in order for this block to, be synchronized with some other block. So you wouldn't want to use like a local variable for this flag, because if I have one block of code synchronizing on one object and another block synchronizing on a different object, those two blocks can run simultaneously, right? So I need to use the same object for each of the blocks that I want to synchronize. But if I have a separate set of blocks I want to synchronize, I would use a different object for those. So that's all very easy to do in here. We have a shared object. This VR, this vote recorder object, is common to all three threads. So we're going to synchronize on that. And so I'm just going to say synchronized parentheses VR. And I'm going to try to compile this to make sure I spelled that correctly. Hey, good job. All right. So that means everything between here and here is locked. And let me do the same thing here. And I'm going to do the same thing as with try-catch blocks. I'm going to synchronize as small a block as I need. I don't need to synchronize in the show votes method. Show votes is just reading the current tallies and printing them out. And I don't care if I do that while somebody's adjusting the tally or somebody else is showing the tally or something like that. So I don't need this to be in that block. And I'd like to make this block as small as possible, right? If I synchronize the entire run method, then whichever thread starts its run method first will have to complete before any other thread begins its run method. And we've killed our parallelism in that case. So you synchronize on the smallest block that you need to, no larger, and then it lets things continue to run in parallel, except when doing so would be dangerous. So the only danger here is if while this is executing in one thread, it's also executing in a different thread. So I put my synchronization around that. So if I compile this and then I run it, bingo, we're back to a fair election, and Yoda wins.
Use the force to get those last few votes.
That's right. Well, I don't know how you do a fair election when people have the force, right? Pull the lever. Not that lever, the other one. All right, so this is really all we need, right? Just yeah. Yeah. So we just need the synchronized keyword, and so the mechanism is pretty simple to use. The tricky part is knowing when and where to use it, and this is partially an experience thing. And sometimes it comes from, working on a big project and testing it thoroughly and then deploying it and finding out that there's a bug. And, your code hangs up now and then, or it misbehaves, or it loses information or something like that. And then it's going through the code in detail with a mindset of, where could I be having conflict with other threads. And it's not always obvious. But there's some things that we can kind of assume might cause issues. So I think we looked at this on Tuesday, right? If you look at a lot of the classes in Java, there'll be a warning saying this implementation is not synchronized. And it's warning you that, hey, if two threads try to interact with a linked list at the same time, anything could happen, right? There's nothing in the linked list class that forbids operations that might conflict with one another. And so if I had a shared set of data that could be updated by more than one thread, I probably want to think really hard about, do I want some kind of synchronization there? Even if you're just, adding data to a collection, depending on how that takes place, right? If it's in the form of grab the current collection, add one more thing to it, well, if there's any time between grabbing the collection and adding the thing, again, it's possible another thread, in between those two operations has added 100 things to the collection, and you might overwrite those changes. So, should not be a problem in PA4 or PA5, right? PA4 is not threaded. Should not be a problem in PA5, because our one thread we're going to create is going to be very well behaved. It's not going to be interacting with other threads. But like I say, in a system programming course, you'll experiment with this and look at different techniques, especially in C, for dealing with these kinds of issues. And this is just sort of a very high-level first view of this. There's a lot of nuance and detail. There's different versions of this that have different characteristics, but it's the same basic behavior, which is two processes sharing a resource in a way that's not safe. And so someone asked yesterday, what if instead of doing this, because this is kind of goofy, get the count, add one, set the count back. What if we just had a method in the vote recorder called, vote for Yoda or vote for Darth? And inside that single vote recorder, we could go ahead and do this update. And that would work better because it would be a shorter operation, but it's still got the same problem that inside the vote recorder, there'd be a set of code saying, take the current total for Yoda, add 1, save that back in, wherever that total is stored. And if we have 2 different threads that could be calling that vote for Yoda method, then you might have 2 instances of those instructions being executed. And if in between here and here something else happens, right, then you might lose the effect of one of those threads. So synchronize is a nice keyword to take care of that. And just to kind of see what happens, if we synchronize the whole machine, so here I'm synchronizing the entire span of people voting. Right? Well, it works, but we've lost our parallelism. Right? So in this previous example, well, maybe that wasn't happening in the previous. Yeah, so in the previous example, we had some voting going on for both Darth Vader and Yoda at the same time, right? Yoda got up to 410, and we started getting some votes for Darth, and then we got a few more votes for Yoda, and so on and so forth. In this new version where I'm synchronizing the entire for loop, once a for loop begins, no corresponding for loop can start in another thread. And so in here we get all of Yoda's votes, and then we get all of Darth Vader's votes, and then we get the next 150 of Yoda's votes, and the next 100 of, well, actually this jumped up, right? So we got all of Darth Vader's votes, and then we got the last 150 for Yoda, and then the last 100 for Darth. I think I put my show votes in the wrong spot in that second loop. So you want to keep these totals as small as these synchronized blocks as small as possible. And making a big synchronized block will certainly fix synchronization issues, but if you destroy the parallelism, you've defeated the whole idea of using threads, which is to have things happening simultaneously. All right, so any questions? Any other questions around that? All right, well, let's talk about PA5. So PA5 is your last programming assignment of the quarter, or last assignment of Clark College. And it's a fun one. So PA5 is the networked version of DOTS. So aka NetDot. And this is usually something you can build on top of PA4. So you want to finish PA4 first. You've got till Friday for that. But the code from PA4, you can reuse that in PA5. And usually this assignment is a matter of adding some extra stuff to it, maybe moving around a few things from PA4, but you should not have to rewrite your DOTS game to any kind of large degree. It should mostly be a matter of taking the game you already turned in and then just sort of tweaking it a little, adding a networked layer on top. And so I haven't redescribed the DOTS game in here and so on. Everything from PA4 that talks about DOTS and how you play and so on still applies here. Alright, this is also a group project if you like, and it's up to you. You can stay with the same group, you can change groups, you can decide to work alone. If you worked alone for 4, you can work in a group for 5. Totally up to you. Just be considerate of people. If you were working in a group and you decide you're going to switch groups or work alone, you probably want to like mention that to your group members if they might be waiting for you to contribute to the project. So communication, right? But groups up to 3 people at your discretion. And as before, you know, make sure you coordinate who's going to turn in the tar file to Canvas, and make sure everybody's name is in the top of every .java file, to make sure everyone in the group gets credit. So let me show you what this game looks like when we play it. And this can be played across distinct machines, but I'm just going to run it from one machine. So for me, I've got this written as a set of 4 classes. I have the 3 classes from PA4, which for me was you know, it used to be dot, now it's net.java. That's the main method, and you know, starts the whole swing thing running. Main panel, which is my J panel, and then box, which is the box class. So I have a 4th class called sock thread, and this is going to handle the networking, and we'll talk about the details of that. But to run this, I can just say java net dot, and it'll go ahead and create this pop-up window. And if I want to run this from 2 instances, right, I can open another window and say java net dot, and I get another window popping up. All right, so these happen to be on the same machine. They could be on separate machines. So first thing to know is that when we're doing this kind of thing, we have a notion of a client-server pair. And client-server is a general concept in networks, but the basic idea is you have a server, which is sort of like, you know, some central location that's providing a service, right? So this could be a web server that delivers the contents of web pages. It could be a print server that takes print jobs and sends them to the physical printer. It could be a time server that tells you what the current time is. And with a server, you usually have a series of clients. And these clients can communicate with the server, and maybe the server sends some information back to them. And it's a way to have sort of one central location that manages multiple requests from different parties. So a print server, you know, when this client wants to print a job, it makes a connection to this server and says, hey, here's some information to print, thank you. It goes away. This client's sending something, this client's sending something. The server is keeping track of these. It's saying, okay, well, I'm printing something right now, so I can't print anything else, but I'll take this file and I'll save it in this temporary location, and I'll save this one, and I'll save this one. And then when the printer's free, it'll say, well, this client had a higher priority, so I'll print that file next, and so on. So we're going to use that client-server idea for our NetDots game. So one of the players is going to be the server, the other is going to be the client. So you're going to have a pair of radio buttons, and we'll talk about how to do radio buttons in Swing, probably on Tuesday. You're going to have a pair of radio buttons to say, am I the server or am I the client? And one player wants to be the server, the other is the client. You have to agree on that ahead of time. And when you choose which side you're going to be, your GUI will change a little bit. So if you're the server, you have to do the following 2 things. One, you have to specify your name, right? Server is always player 1, so I can't specify player 2, but I can put in my name for player 1, and then I need to hit the start button. And with this client-server model, the server has to be running before the client start asking the server to do something. So whoever's going to be player 1, make yourself the server, put in your name, hit the start button. And now we're just kind of hanging out waiting, and we can't, you know, click in here yet. That's a bogus message. Wow. Until we get a client to connect to us. So the client, right? Click the radio button for client. Put in your username. So this will be I don't know. This will be JJ. And you also need to specify the name of the machine you want to connect to. So if I was on a different machine, I could connect to, 192.168.0.101. That's the name of my laptop. Or I could put in, the actual name of it, like octopi.com, which is my machine in the garage. Or you can just use localhost. And localhost means this machine that you're already on. So it's a synonym for 127.0.0.1. Which is always an IP address that loops back to your current machine. Alright, and the client, they have a button that says connect. So they hit this button to connect, and now the game is live. And so the server over here, they can see player 2's name is JJ. Player 2 can see player 1's name, that's Nick. Both players are seeing, hey, it's player 1's turn, player 1 is Nick. If player 2 tries to click right now, it's not going to do anything. And I'm getting debug messages while I'm doing this saying, hey, it's not your turn. Alright, so player 1 goes, they can click anywhere that they want, and when they make a click, wow, I found a bug in my program. Wow, I just lost like 1 billion points. Alright, don't do like I did, right? So don't accept mouse clicks until the other player has connected to you. Alright, so forget that you saw that. Alright, we'll have JJ play again. Alright, so Nick makes a move. I can click right here. And the following things happen, right? As with PA4, you see a line drawn. And it switches to the other player's turn, player 2. But on the other player's screen, the exact same things happen. This line gets drawn, it says it's player 2. And now if I try to click, it's going to, ignore me because it's not my turn. So player 2 can click, line gets drawn, and I see it over here, and now it's player 1's turn. So I can go there, and JJ completes a box. The initial gets filled in, it's still player 2's turn, and I have the exact same output on the server side. And it's still player 2's turn, so these clicks get ignored. So player 2 can go, now it's Nick's turn, and there's JJ and Nick. And JJ and Nick. And JJ goes right here. Alright, and so now Nick is going to go right here, which fills in that box, puts the initial in, adds it to the score, so it's 1-1, and it's still Nick's turn. And now I'm going to click right here in the middle. This is going to complete 2 boxes. So N appears in both of those. The score goes up to 3-1. It's still Nick's turn. And the same thing is reflected on this client side. And it's still Nick's turn, so these clicks get ignored. And there's Nick's move. And player 2's move, and so on. So it plays out exactly the same as PA4, except instead of sharing a mouse, right, each of these windows could be on a different machine. Each player has their own mouse, their own display, and what happens on one screen gets echoed on the other screen. Alright, and the connect button and the start button get changed to a quit button. There's no replay option on this one. There's just a button to quit, and if either player hits the quit button, both windows exit. And the game's over. Alright, so that's the experience we're after.
Are we going to hardwire this to 127.0.0.1?
No. So when you run this, if you're the client, you can put in a host name here. So I could say, google.com and try to connect to a net.server on Google, and it's not going to connect. So I'm not going to be able to do anything until something happens over there, and this connection will probably time out after a few minutes. But
So just a raw IP?
yeah, so you can put in a name or you can put in a raw IP. And so if you want to test this on a home network, right, you could put in, 192.168.0 dot whatever, if that's your intranet, and, run this on 2 different laptops, and play it like that. Or if you have port forwarding set up, and we'll talk about ports and what port to use and so on. But if you have port forwarding set up, you could run this between 2 different intranets. So if you have a friend with a home network and you know the IP address of their router, you could put that in, and if their router is forwarding port 1234 to their machine, you could play against, your friend at a different location, or if they're up on the space station or whatever. So I had a student last year who went to town on this assignment, and not only made it so that you could have an unlimited number of people all playing the same game, but he took a Android development course at WSU this semester, and he ported NetDots to his phone for his final project. And he did it in a way that you can actually, run one instance of the game on a PC and the other one on his phone, and you can play, from device to device under totally different operating systems. And the way I'm going to describe, setting up the network communications, that kind of happens for free. And so you can play, from Linux to Windows, or Windows to Android, or Linux to Linux, or any combination like that. And it's part of kind of the magic / miracle of networking that this stuff works so well. And that's part of the goal of this project, is to really kind of sort of demystify the fact that I can run pretty much any web browser on any machine and access pretty much any web server on any machine. I can have a Raspberry Pi and pull down web pages, and they'll look the same as if I do this on a Linux laptop or a Windows machine or whatever. So we got a lot of parts and pieces to break down and put together for this. Let's go ahead and do a 5-minute break, and I'm going to fix that little bug in my code because it's going to bother me otherwise. So let's take a break, and let's come back at just over 5 minutes. All right, so I'll see you back here in 5, and we'll start digging into the details of this. Alright, we are back. I still have my camera. Awesome. Alright, so here's what you want to have happen. Right, run Java net.dot, you get one instance of it. Run a second one. And so one of them can be the server, that can be Nick. These clicks should have no effect. Go ahead and say start. These clicks should still have no effect until somebody else connects. And then the game begins, and now it's one click per player. And so on. Dang, you missed all of that glorious commentary I just did. Alright, sorry. Yeah, so here's the behavior you want, right? Basically when you run your two instances of net.dot, one of them will be the server. Mouse clicks should have no effect. Go ahead and say start. That will start the server listening for connections. Mouse clicks should still have no effect. Another player can connect, so put in player 2's name and say connect. And now you're starting with a clean slate, so the first click over here is transmitted and so on and so forth. So I had a glitch in that previous demo where clicks in here before the other player connected were being registered silently, so make sure your game is running before you acknowledge mouse clicks. Otherwise, just treat them as no ops. Alright, so let's dig into the details of PA5. So requirements. So some of this I'm going to specify as requirements, and some of it I'm going to talk about as suggestions, and some of it I'm not going to talk about at all, and it's totally up to you. The requirements are the following. You need to have a pair of radio buttons for choosing whether you want to be the client or the server. And so radio buttons are these buttons that you can select exactly one of, and only one at a time. So these things right here, these are radio buttons. And if I select server, then client gets deselected. If I select client, then server gets deselected. And this is a swing object, and or swing class. We'll talk about it on Tuesday if you need help with it. But it's a straightforward mechanism for hooking these two together so that you push one and the other gets unpushed. So you need a pair of radio buttons to choose whether you're going to be the client or the server. Player 1 will be the server, player 2 will be the client. And you can assume that player 1, the server, is going to start executing their code before the client or player 2 executes their code. So the server will always exist first. And then depending on whether you're client or server, your buttons and widgets change. So server should have a box for player 1 and a start button. Client should have a box for player 2, a connect button, and an additional box for specifying the machine you want to connect to. Alright, for the server, the start button will create what's called a server socket. We're going to talk about these next. But it's basically a connection point, and these connection points have addresses. The address for the port for the server socket is going to be 1234, and that's just the address we're going to use. It's kind of a random address. For player 2, for the server, player 2 text field is not editable. So if I'm the server, I can type in here, but I shouldn't be able to type in here because this is going to be filled in by player 2. And if no name is specified, if this is blank and the person hits start, fill in the name server. Right? This is for my benefit so that when I'm testing I don't have to type in a name here. I can just run your code twice, and one of them hit the server, say connect, the other one say client, and hit connect, and I don't have to type in the names. So default username for player 1 is server, and it should do whatever it has to do at that point once I say start, to note that this is, player 1 internally, and to sit here and wait for a connection to be made. Okay, if you choose the radio button that says you're a client, then you want to create this let me get out of here. Then you want to create this text field down here for specifying a host name. So that's the address of a machine that you're trying to connect to. The start button gets renamed connect. And when the connect button is clicked, it will try to connect to port 1234 on whatever machine you specified in here, localhost being just your own machine. And player 2 can be typed in, and player 1 is empty. And if no name is specified for player 2, the default name is just client. And that's, again, to make it, faster for me to test. And once the player connects, it should note that it's the other player's turn and it's waiting for player 1 to make a move. All right, so that's just the start. And that stuff, most of this you can do without knowing anything about networks, right? This is enough to keep you busy for at least part of the weekend, just setting up these different widgets that you're going to display, changing with the radio buttons and so on and so forth. If you can't figure out radio buttons, just make them push buttons for now, and we'll switch them later. All right, once the start button or connect button has been pressed, the button is relabeled quit and is used to terminate gameplay. There's no replay button here. You don't have to ask if you want to play again. As soon as the person says quit, you can just exit the game. All right, so the following things happen when a connection has been made. So the server has hit start, the client has hit connect, connection is established. So at that point, you want to send your name to the other player and then read the other player's name. Okay, this is so that, each person can show the name of not only yourself, but the person that you're playing against, and knows, what their initials are. So you're going to swap names and update the GUI, and then basically you take turns clicking. And at any point, each instance of the game knows whose turn it is. If it's your turn, it's just PA4. You click the mouse somewhere, it gets the XY coordinates, it translates it to a box, it checks the edge, and so on and so forth. But if it's the other player's turn, instead of waiting for a mouse click, you wait for a message to come in from the network. And the other player whose turn it is, when they click the mouse, in addition to doing all the PA4 stuff at the very end, they send a message to you saying, hey, I just clicked the mouse, here's the XY coordinates. And your code, right, remember it's not your turn, it's the other player's turn, you receive this message, well, you just treat that like a mouse click. And it's the same PA4 code again. PA4 code, if it's the other person's turn, and they click, at XY, a line gets drawn. If a box is completed, their initial goes in, and so on. Exactly the same thing here. But you're alternating. First, you're going to read your mouse click. Then, you're going to receive information about a mouse click through the network. Then, you're going to go back and wait for your mouse click. Then, you're going to receive information about a mouse click through the network. And you just switch between those two. How do you know which of those two? Well, it depends whose turn it is. If you're player 1 and it's player 1's turn, you're waiting for a mouse click. If you're player 1 and it's player 2's turn, you are ignoring mouse clicks and you're waiting for a message from the network saying, oh, the other player just clicked at, 17,205. The cool thing about this is, when I ran this a few minutes ago, we had two windows. And if I clicked over here and I drew a line, you saw that line get drawn in the other window also. And if an initial got painted in this window, the initial got painted in this other window also. But those are happening kind of independently of each other. And what you have is basically two versions of PA4 running, and you're just sharing mouse click information. So think about it like this. So when I was a kid, my mom used to like playing Yahtzee. It's a dice game. And she used to play with a friend, and her friend moved away to another part of the state. And so once a week, they would get together on the phone, and they would play Yahtzee over the phone. And it's a dice game. You roll the dice, and depending on what comes up, you get to do certain things on your scorecard. Well, how do you do this on a telephone? Well, you know, whoever's turn it was, they'd roll the dice, and they would tell the other person what the dice came up. They'd say, okay, I got 2 5s, a 3, a 1, and a 6. Thank you. That's basically what we're doing here. Right? So imagine that you and a friend both had copies of your PA4. So you could call up your friend, and you could say, okay, let's play. I'm going to be player 1, you can be player 2. Okay. So you're going to move your mouse somewhere and click. Right? And all you have to do is tell your friend, okay, I'm clicking at x equals 17, y equals 25. And you click there, and your friend clicks on their instance of PA4. Well, both games are going to do exactly the same thing. And you both know, you know, if a box was completed, and so both of your games are going to say, okay, it's player 1's turn, or it's player 2's turn. And if it's player 2's turn, your friend is going to say, okay, I'm clicking the mouse at, you know, 195, 218. And so they click the mouse on their game, and you move your mouse to those coordinates and click the mouse on your game. And again, both of your boards will do the same thing. They'll draw the exact same line. If it completes a box, you'll see 2 boxes. Both of those boxes will have an initial. The thing that's tracking whose turn it is will continue to say it's player 2's turn, right? And this happens almost for free. So you don't need to do a whole lot of passing of information back and forth. You don't need to tell each other what the score is or how many boxes are completed or whose turn it is. All you've got to convey is mouse clicks. And if you approach it from that mindset, this becomes a much simpler project. Because it's just one piece of information you have to send, XY coordinates of a mouse click. Alright, so some suggestions. Right, start with your PA4 code. If you finish PA4 and it feels kind of wonky, like, you know, you had to make a bunch of changes and undo some things you did and so on, you may want to clean it up a little. Right? Try to get it in a state where you feel really comfortable with PA4, like really solid understanding of it. And I can take this, I can take it apart, put it together, I can explain it to my dog, and my dog will understand it, right? So don't be afraid to spend a little bit of time kind of polishing PA4 to get it in a state where you're comfortable messing with it. So we're going to use a single thread in here. I'm calling it a net thread. And you pretty much need to have a separate thread because a lot of what we're going to be doing is waiting for a message to come from the other user. And we can't do that in our mouse click code. If we do that, our whole game is going to look frozen. Right? So here's what you don't want to do. Get a mouse click, update your board, send a message to the other player, and then sit in a loop and wait until you get a message from the other player. If you do that loop inside the mouse handler, your GUI is going to look weird. Right? It's going to be frozen. If you try to resize the window, it's going to look weird, and so on and so forth. So we're going to have a separate thread whose whole job is to get messages from the other player and to take action on those. So we're going to have one thread. I'm calling it net thread. You'll call it start method in the beginning. It will establish a connection to the other player through the network, and then it'll just kind of hang out and receive messages and possibly send them also. All right. You don't need to synchronize anything, so this is not synchronized as in what we talked about with threads and deadlock and so on. But these programs move in lockstep, right? They both know whose turn it is, they both know how many boxes are filled in and so on. As long as the same thing happens in both games, the boards will stay synchronized with one another. So here's the real guts of the behavior. If it's your turn, you basically do nothing until the mouse gets clicked. Your mouse handler, your mouse listener, checks to make sure it's your turn, and if it is, right, update all the data structures, the Boolean edges, and so on and so forth. Call your repaint method, but at the very end, before you return from the mouse listener, send a message to the other player and tell them where that mouse click happened. And you can do that by just running a method inside your netthread class to send that information. And now it's the other player's turn. You don't do anything, right? Your code is just kind of off, sleeping. But your net thread is waiting for a message to come in from the other player. And when the other player takes a turn, they click the mouse, they'll send you a message with the XY coordinates of the mouse click. Your net thread will receive that XY pair and then do the same thing as if you clicked the mouse at that point XY. So call all of your code that does the translation from XY to row column, find the edge, and so on and so forth. And then switch your flag to say, okay, now it's your turn again. So 2 changes you make, right? One, at the end of your mouse listener, send your XY coordinates to the other player. And 2, have a separate thread that's receiving messages from the other player and basically calls your mouse click code when you get an XY pair. Now, don't actually call the mouse listener, but there was this suggestion that in your mouse listener, you want to do all of these things, right? Throw all of this stuff in a separate method. For a mouse click, get the XY coordinates of the mouse click and then call this code with that XY. For the net thread, get the XY pair from the other player and then call all of this code with that XY pair. So it's really like 2 changes, 2 additions to PA4. But the details of those can be interesting. All right. So network protocol, there's 3 types of messages we have to pass between the 2 players. The first is in the very beginning, we want to swap names so you can see the other player's name. The general message we're going to pass is just a pair of XY coordinates for mouse clicks. And then some sort of special quit message to say, hey, the game is ending, the other person hit the quit button, let's just get out of here. And how you organize this is up to you, but here's a suggestion for these networks. As soon as you get a connection established, so the server has started, the client has said connect, as soon as you know that there's a connection established, send your name to the other player, and then read 1 line back from the network, which will be the other player's name. Right? Make sure you send before you try to receive. And that's a one-time initialization. And then when you want to send XY coordinates for a mouse click, just send 1 line. And I'm suggesting the letter C, space, the X coordinate, space, Y coordinate. So just make a 1-line message. It's just a, concatenation of strings. Send that to the other player. When you receive a message like CXY, split it into pieces. So there's a split method in the string class. If this is in a string called, input, I can say input.split parentheses, quote space. And I'll get an array of words. Element 0 will be a C, element 1 will be X, element 2 will be Y. So I can take element 1 of that array, pass it to integer parseInt, that'll give me an integer, that's the X coordinate. Element 2, same thing, that'll give me the Y coordinate. And then the third type of message is just the letter Q. And if I'm waiting for a message like this, and instead I get the letter Q, I know the other player quit, I'll just shut down my GUI, close everything out, and just exit. You can do this however you like, but if you follow these suggestions, your game should work with other people's games. Right? Someone from a different group could run their code, and you should be able to set up a connection to their code, and it should work perfectly fine if you're using this protocol. If you use your own protocol, that's fine too, because I'm going to test your code against itself. Right? I'm going to run 2 instances of your code. One is client, one is server. But if you want to have more fun with it, right, you could stick to this protocol, and then you can try playing, across the net with other people, and see if your code works together.
Could we try making this UDP instead of TCP?
I would say do it as TCP because on the tests I'm going to test you on creating TCP sockets and such.
All right.
So let's get that experience here. All right, so I'm going to test your code against itself. You'll probably develop this in Eclipse, at least initially, but I'll be testing it, on the command line standalone. So I'll just be saying Java netdot twice, and getting it to work like that. And then grading, this is pretty straightforward. So downloadable and compilable, 15 points. Drawing the GUI with the required fields, that's another 15. Having radio buttons that change the appearance of the GUI as described, that's another 10. So 40 points just for the GUI itself, right? Having the start button and the connect buttons establish a connection, that's another 10 points. So you can get half your points without actually doing anything related to netdots or network communication. You just have to start a connection. Swap your names in the beginning, that's another 10. Now you're up to a 60. And then big 20 points if you can respond to mouse clicks correctly. And this is really the guts of the program, right? Swapping mouse information, drawing lines in sync on both boards, and so on and so forth. And so this is where having a properly working PA4 will be essential. And then tracking player's turn, not allowing out of turn mouse clicks, that's another 10. And then the quit button gets you your final 10 points. And submission as usual. Main class should be netdot, so you need a netdot.java. Take all of your .java files, put them into a tar file, upload to Canvas. Make sure you use the default package. Make sure your code works outside of Eclipse by saying just java netdot. Alright, that's a lot of details. Questions on all of that?
I think I'll have more next week.
Yeah, this is a lot to just sort of like take in a vacuum. So once you start working with this, I would expect questions to come up. Let me make a comment about working in Eclipse. And I tried to do this in yesterday's class and it didn't work, and so I posted a bonus video after class describing just this part. But I'll go ahead and go through this in here also. Assuming that you're going to be developing an Eclipse, you're working on a program that necessarily involves, two instances of your program running at once. And this is one of these things where, you might be executing your code, a few hundred times over the course of working on this project, right? And you'd like to have a very rapid development cycle so that when you're debugging, if you think that, making some change will help, it doesn't take you 5 minutes to make that change. Because, you're not only slowing down how quickly you can go through these development tries, but you're distracting yourself, right? You've got some idea, it could be this or that. Well, let me try this. 5 minutes later, you get to try it and it doesn't work. Okay, what was the other thing I was going to try? So you want to try to streamline your environment. This is not just PA5, this is life, right? Anytime you're doing anything with programming, you want your environment to be as streamlined as possible. You don't want your tools getting in the way of you. You don't want things distracting you. And this is a really good example where Eclipse can be a pain in your development. And so one thing you can do, if you're developing this from the command line, it's not a problem. You just have two windows, right? And one window where you edit your code, two windows where you run your code from. It's great. If you're working with Eclipse, let's suppose that this was my GUI, right? And that doesn't generate a lot of output. Let me find a better program. Yeah, Painter I broke. Alright, so here's a program. I can run it. Oh, man. Alright, we'll just go with that first one. Okay, so here's some code. I can click anywhere I want and I get my XY coordinates. So suppose this is your dots game, right? And you're trying to test it. So you're going to want to run 2 instances of this. So I can hit the run button again, and it complains it's already running. But I've got 2 windows popping up here. And if I click in this window, it tells me my XY coordinates. And if I click in this window, it tells me my XY coordinates. And this is confusing, right? If I've got debug messages coming, let's say this is my server and this is my client, I don't want the messages from my server and my client getting mixed together, right? That's going to be really, really confusing. So some things you can do, I can come under here and I can hit this drop down over here, and I can say make a new console view. Okay, so I've got a second console up here. Normally that will end up as another tab in here, but you can move these tabs around and place them somewhere else. So I'm going to make a new console view, and I'm going to drag it up here just so that I can look at both of my consoles at the same time. Possibly. Okay, I should not be doing this while I'm running.
They get the manually stop the other one too.
This is true. Thank you. I should probably not be doing this while I'm zooming and recording and mining for Bitcoin and whatever else I'm doing. All right, so I've got 2 console windows. Okay, you can specify that, for example, I want. Let's go ahead and run my 2 instances. And so I can specify that this window up here, if I click this drop down, I can say I want that to be my first instance, right? And this window down here, I can set this to be my second instance. And then you got to do something kind of subtle, because right now, if I click in here, it comes out on both windows. And if I click in here, it comes out in both windows. And so what's happening is this is switching around dynamically based on where output is being produced. So let me change this one back to 1. And this little button right here says show console when standard out changes. Just uncheck that. And if you uncheck that, now this window is console 1, this window is console 2. And now if I click over here, I see it in the top window. If I click over here, I see it in the bottom window. And once you get this set up, it'll remember it, right? But you have to set it up once. And if you have a bigger display than this, you can make these things set up somewhere so you don't have to keep moving things out of the way, right? The worst possible situation is something like this, right? Where I come over here and I click, and then I have to come here to see what got printed, and then I have to come here, and maybe I accidentally click when I switch. And so set things up in a way that makes sense for you, right? It may seem obvious, and it may seem like a small thing, but trust me, you'll be running this code a lot, right? If you're lucky, you'll only run it a few hundred times between now and when you turn it in. And don't give yourself extra work to do every time that you run it. So there's separate stop buttons for each window, and so on and so forth. All right, so that's just hints from Heloise kind of stuff to think about. But like I say, once you get beyond designing the GUI, you can do most of your development from the command line. And I'm a fan of the command line, right? and you can just VI to edit your code, and then you can just run your main class twice to test it, and you'll have two separate windows with output and so on and so forth. Let's see. Yeah, you can also tag your messages with a keyword in front, like client or server, to say who it's coming from. That's a good practice. All right, let's talk about the goods. Let's talk about sockets and client servers and networked communication and all of that stuff. So we started talking about client server, and this is a model that is used for a lot of stuff in computing. Like I said, printers, web servers, and so on and so forth. When you log into the Linux server, and you say, SSH client, there's a server on linuxengrcs.com called SSHD. It's a program, and its whole purpose is to listen for connections from clients, and in this case the client is a program called SSH. And there's a communication protocol. When SSH connects to this SSHD, certain information is exchanged. And if the correct information is exchanged, then you can proceed to specify your username and your password. And that information is, sent encrypted, and so there's a decryption that takes place on the server side and so on. And then credentials are checked, and if everything works the way it's supposed to and you're authorized, then a new process begins over here running bash, and there's two-way communication between that process and your SSH client. And it may be that you're connecting to the Linux server using PuTTY. It's exactly the same proposition. There's code inside PuTTY that creates this connection point and does the same thing that SSH does, as far as sending messages out and encrypting and so on and so forth. And if you log in from your phone, you can run, Termux on your phone, and that's an Android application that does the same thing that SSH does. It creates a connection point, it goes out to the network, it looks for the SSHD server, and so on and so forth. So, one concept we need to talk about is ports. So on any given machine, there are usually multiple servers running. There's a web server, there's an SSH server, there's a print server, there might be a mail server, there might be an FTP server. Each of these servers needs to be identified. And so it has an address which is called a port, or a port number. Port number is just a 16-bit address that identifies a particular server. So for NetDot, the game we're playing, our port number is going to be 1234. It's a kind of random, but not entirely random, 16-bit number. It's not one that's earmarked for any particular use right now. So there's a very good chance nothing on your system is currently using port 1234.
Aren't you supposed to leave like the first 5,000 alone?
Possibly. That would be if you follow rules, I guess. So if you look on a Linux machine under etc services, you'll see a list of typical port numbers. Now the first 256 ports, 0 through 255, those are reserved. And you cannot bind those numbers to a socket unless you have root access. So they're actually protected. And that's because they're very standardized. So, for example, the old way we used to send files from machine to machine was to use something called FTP, File Transfer Protocol. And that always happened over port 21. So there was an FTP server, or a daemon, which is why it's called FTPD, which would run and have a port with address 21 waiting for clients to come in and say, hey, I want to transfer some files. The old way you would connect to another machine instead of SSH was to use Telnet, and that was port 23. The secure version of that, SSH, is port 22. So Telnet still exists. It's a great program to use. It's just not secure. So if you were to send, your username and password or the secret ingredients for your chocolate chip cookie recipe, you wouldn't want to use Telnet, right? Because it just sends plain information over the network. But there's nothing inherently insecure about that, right? It's not something you'd use to send critical information. Port 20.
For debugging, though.
Yeah, it's great for debugging, and I'm going to recommend it for debugging NetDot too. So SMTP, that's a simple mail transfer protocol, that was on port 25, and so on. So there's all these services that used to exist on machines, and I could make a connection to port 79 on a machine and type a username, and it would tell me information about that user. Are they logged in? When did they last read mail? What's their plan? And so on and so forth. Okay, so port 80, hey, that's HTTP. That was the original port for web servers. But it's unsecure. It's not encrypted. And so port 8080, that's the one we use for secure web connections, web server connections. There's a port for Minecraft. It's like, I don't know, 14,000 something or 45,000 or something. That's the Minecraft server. If you're running a server on your system, that port will be in use. So there's all these ports, and some of them are very standardized, and some of them probably don't come up. Like, I don't have a Lotus Notes server running on my system, but if I did, it might be port 1352.
But could I ask a question about ports? I've never figured this out.
Sure thing.
What happens if you have a collision?
You can't really.
Oh, you can't?
So once a socket, we're going to talk about sockets too, but once a server has been given port number N, if another server tries to use that same port number, it'll say that's already in use.
Okay.
And that's pretty much no way around that. Otherwise, there'd be confusion when I tried to talk to port 23. If there were two servers that were listening to that port, it would be confusing. So that's why we kind of allocate these for specific things.
Is there any kind of way to write defensive code around that? Like, I need to know if XYZ is in use, and what can I use?
So I don't know if there's a best practice for if you're just looking for a port number. There's probably something that'll say, give me the next available port number. But if you're creating a server, theoretically you're waiting for someone to connect to it, and they need to know what address to connect to. So we don't usually just kind of pick a random free port, unless we then had some way to broadcast that port number to the clients. And we can't really do that until we've got a connection to them. So it's more common to just kind of pick an address and use it. Now, to know if an address is in use, one thing you can do is try to bind it to a socket. But from a command line, I can run a command called netstat. And if I say netstat-a, it'll show me my active network connections. And if I restrict that to just TCP connections, I can see everything that's going on my system right now as far as TCP connections. So these are local addresses, these are foreign addresses. So there's currently a connection between 192.168.0.2 and my machine. My machine's called Nitro. That's the brand name. And it's whatever this is listening on a port with address 46.672 and 192.168.0.2. I don't know what machine that is. It's something in the room here. Here's a connection I established to some other machines. Well, these are using HTTPS, so this is a web page I've got up somewhere. Here's something Microsoft, and so on and so forth. And some of these connections are established. Some of them are in the process of being closed. Some of them have been closed and they're just waiting to disappear. And some of these are listening to see if other things want to connect. These are servers.
Is there like some sort of practice if you're hosting enough servers to where you might exceed a 16-bit number?
The argument, well, so it depends what language you're using to create these sockets. But if you tried to pass something bigger, it would either get truncated or you might get an error from the function that you call, saying it's not a legal port number. But I think that's a hard limit inside the TCP/IP protocol.
I mean, it's probably pretty silly to expect that you're going to run out of ports on your own machine.
You could. I mean, and you can certainly deliberately run out of ports. You can just start creating a bunch of sockets and binding them to sequential ports, and use up resources. But in general, 65,000 ports probably plenty for now. And the other thing I should mention at this point, it's topical, is if I have 3 clients connecting to this SSH server, right? Each of these clients ends up connecting to a different port number on the remote machine, so you are kind of limited in how many connections you could have at once. And that's just a resource issue. But right now, probably not a typical machine that could run 65,000 simultaneous connections. Even the blazing Nitro laptop. So if I start my NetDot program, and let me just throw this in the background, and let me run my netstat command again, and if I look carefully, so let me do netstat-a-n, which replaces these names with numbers. And somewhere in here I should find a connection to port 1234. Yeah, I'm being blind right now. Oh, I haven't started my server yet. Alright, so I'm going to start my server. And now if I look at my network connections, $1 billion for the first person who spots it. Oh, I spotted it. 1, 2, 3, 4. So there's my server socket, right? Hanging out here, waiting for a connection to be received. So you can kind of see what's going on using netstat. I recommend downloading and installing netstat on your Linux system, because it's useful when you're doing networking. You just kind of see, and you can do grep to just find that socket and so on. And then telnet can be useful. So I have a protocol set up which is described in PA5, where I say, once you establish a connection, send your name to the other player, wait for the other player to send your name, and then start swapping mouse clicks by saying CXY. So I can say, telnet localhost port 1234, and I get a message n space Nick. So that tells me, hey, the other player's name is Nick. And I'm going to say n space me. And now my game thinks the other player's name is me. And I'm waiting for I'm getting print messages here. Oh, I shouldn't have done this. Alright, hold on. Let me do this again. My NetDot program prints out debug messages. So let me do this without the debug messages. Let me start this. Let me make myself a server and start that. And so let me just do a telnet. Alright, so it sent n followed by the name. Its name was server because I didn't specify it. So I'm going to send my name, and my name is Nick. So now it says, you know, second player is Nick. And it's currently player 1's move. So when I make a click somewhere, what happens? It sends a pair of XY coordinates to, you know, in this case it's telnet, but this could be, you know, the other instance of the game. And now I can send, you know, I would wait for the person to click somewhere, and if I click, say, over here, like around 300 or so, I would send those coordinates, so I could say, you know, X 303 and Y 312. And the server program sees that as a mouse click, draws a line, now it's back to being player 1's turn. So you can you know, do some debugging by using telnet. I don't know how much that will help you, because for this to be working, right, I have to have the whole network structure set up. But if it's not working, if it should be working and it's not, right, you can hop in with telnet and sometimes use that to sort of see what's being passed from the game window here. Telnet, by the way, if you want to get out of it, do a control right bracket and then a Q for quit. And I should have sent a quit message because now this thing is waiting to quit. Alright, so client server. General protocol for sharing information. And so to be able to find a server, we have to know its port number. That's its address. And when we create this server, our code is going to say, hey, give this the address, you know, 1234 or whatever. And so this is done using a pair of mechanisms called sockets. And there's two types of sockets in Java. There's a server socket, which, guess what, it's created by a server. And then there's just a plain socket, which is created by a client. And the basic setup is this. A process creates a server socket with a particular port number. And then a client creates a socket and says, hey, connect to the socket with that port number. And if everything goes correctly, you get this kind of two-way conduit between these two sockets. And once you have a socket, you can construct a scanner from that socket so that you can read from it using, you know, has next line, and so on. You can create a print writer from that socket, so you can write things by saying, you know, printwriter.println and put things into the socket. And the setup is, you know, if this process writes something into here and this process tries to read from its socket, it will read whatever got written in over here. And if the server writes something into its socket, the client can read from its socket and it'll read whatever was written by the server. So it's a conduit that you can put something in one end, take it out of the other end. But this stuff in the middle is, you know, potentially the whole internet. So you can do this on one machine, you can do this, you know, from one country to another. And all the mechanisms for routing things through networks and bouncing off the satellites and so on, that's all contained inside the classes for these sockets and, you know, the infrastructure that is the internet. Alright, so let's look at some code. And we're running low on time. Well, we're not really running on low on time, but we're coming to the end of our time today. So we're not going to get through a lot of this, but I'll get you started on server sockets at least, and we'll plan on Tuesday really digging into this, getting through all the details of sockets that you need to be able to set up these communications. We'll do some code examples, and we'll also go through Eclipse and just touch on radio buttons to make sure those aren't an issue. So we'll start this in earnest on Tuesday, but my goal today has been to give you enough to get you thinking about the project once you're done with PA4. Think about going back and polishing PA4 if you need, and maybe start, making some of the changes to the GUI and so on and so forth. But let me show you a little bit about sockets, and we can play with that. So there's two kinds of sockets. There's sockets and server sockets. Server sockets are used by servers, not surprising. Let's talk about them first. So it's a class. It comes under java.net. And you construct a socket by specifying a port number. And that's all you need. If you just say server socket, you've got a socket, but it doesn't have an address yet. So when you give an address to the socket, that's called binding an address to it. So if you construct with an integer port, it binds it to that address. And for us, if we try to use something outside 0 to 65K, we'll get an illegal argument exception. So that's what keeps us legal. And you can also specify what the maximum backlog is. This will prevent some degree of flooding. If somebody tried to make 1 million connections to your server socket, and there was no limit on how many connections could come in, right, you could do a denial of service attack. So we can specify a backlog, and I think this said the default backlog is 50 maximum queue length. And the one method we're going to play with to start is accept. So we're going to create a server socket, we're going to bind it to a port, we'll just pick on 1, 2, 3, 4. And the accept method basically waits for somebody to connect to this socket. And it says the method blocks until a connection is made. So when we call accept, we won't actually come back from that call until somebody connects to the socket. And the full mechanism is, once this connection is established, you're not actually talking to the server socket, but a new socket is created, and that's what you connect to. And the identity of this socket, that comes back from the call to accept. So accept takes no arguments. It returns a socket, which we can use to communicate with the client that connected to us. So that's enough to do some sample code. So we can start with a server socket. And let's just say server socket SS. And we'll create a new server socket on port 1, 2, 3, 4. And we'll wait for a connection. And we'll say connection received, and that's our whole program. Now, everything in networking can throw exceptions, so this constructor can throw an exception, this accept can throw an exception. So I'm going to put a slightly sloppy try-catch block around both of these.
Don't. A class in C# called connection to do just this, like encapsulate me away from all the try-catches.
Okay. Cool. Yeah, just don't let our teachers see what we're doing here. Alright, so if either of these fails, I'll just say error in socket code. Let's go ahead and see what that error message is. We'll print out E, just for fun. Alright, otherwise we'll go ahead and we'll say connection received. Alright, so we can run this, and it just kind of sits there and hangs out. So it's sitting inside that call to accept. And it will sit there forever, so if I look for 1, 2, 3, 4, it's in that listen state, right? So on my local machine, there's a port 1, 2, 3, 4, and it's listening for connections. So if I telnet localhost 1, 2, 3, 4, that will make a connection to the socket. The accept command will return, and my Java program will say connection received. And since it then exits, when it exits, it closes the socket, and so my telnet program said connection closed by foreign host. And now if I look at my netstat, it's in this time wait state where it's shutting down. But it was temporarily connected to, you know, my local machine, 127.0.0.1 port, 40,170. And that connection will go away in a few minutes. Meanwhile, I can do this again, and I can make my telnet connection, and it happens again. And now if I look for connections, I've got 2 connections. That latest one was port 40,174. And both of those are in a time wait state where they're shutting down. Alright, now if I run this, and I've got this connection that's listening, and then I try to run this again, I'll get an exception. The exception is address already in use, bind failed. So I tried to bind a new socket to port 1, 2, 3, 4, it's already in use. If I try to bind this to a port number like 1, 2, 3, I'll get an exception, permission denied. Because without root access, you can't bind a socket to an address 255 or lower. So those things that can happen in the try-catch block are potentially interesting. And so, let's see, we got a couple of minutes left. Let's take a look at accept. Accept returns a socket. So socket is a different type of object. And let's do the following. Let's save the return value from ss.accept. And when we get a connection received, let's just go ahead and print out what that socket object is. And so we'll come in here and we'll do our telnet connection. And so it says connection received, and it tells me the socket that it received the connection from was 127.0.0.1, and there's the port number. And here's the local port, right, the port on the server side that it was connected to. And if I do my netstat, I can see I had a connection between 1, 2, 3, 4 and port 4180, and it's currently shutting down, right? So that's 4180. So if I can push my luck here, Thursday is our Friday, so this will be a Friday demo. So let me see if I can hit this from my phone. I haven't tried this in a while. That's not what I wanted. Terminus. So this is a Telnet client basically for phone, and let me try just connecting to my local machine. So I'm going to go to 192.168.0. I think I'm 101. And I'm going to go to port 1234. And I'm not going to use SSH. I'm going to use Telnet. Nope, I'm not going to use Telnet. I'm just going to do a bare connection. I use Telnet to port 1234. Let me see if I can make our Java program respond. So I'll try connecting there. And there you go. So I received a connection, and the local address that I received from was 192.168.0.214. Well, that happens to be the address of my phone on my home network, and it was port 45968. And again, if I netstat, right, there's the connection that had been established, which is shutting down right now. So a little bit of code gets you really far. Right? It's basically 2 lines of code: construct a server socket, accept a connection. And that's enough to, you know, make a communication conduit between my phone and my laptop, which is pretty cool. So what do we have to do Tuesday? We have to talk about sockets, right, which is the other end of the communication, and it's just another class in Java. You can look at the manual pages for it, but basically when you create a socket, you're going to construct it with an internet address and a port number. So the server socket, you just need a port number. The client socket, you specify the address of the machine you're trying to connect to and the port number of the socket you want to connect to. And it gives you back an object of type socket. And once you have that, you can, like I said, construct a scanner and a print writer pair, and that lets you print into one end of the socket and you can read from the other. And so we'll do some sample code to do that, and that will really be all the networking you need for PA5. Making a pair of sockets, a server socket and a plain socket, establishing a connection, and then making a scanner and print writer to send information back and forth. So we'll do that on Tuesday. We'll look at radio buttons on Tuesday, and then we'll move forward from there. We're going to talk a little more about sockets and servers and client server models and so on. But then we're also going to sort of blow past all of that lower level stuff and look at some other classes, including this this convenient class called URL. And URL is a class we can construct by specifying a URL, and we can create an object of this type with a string of, you know, clark.edu, and we can start reading Clark's web page, right? And there's a pretty simple set of methods we can use to say, hey, you know, give me the information from this web server. And then we're going to put that together with some other swing objects, and we'll actually be able to make a web browser with, you know, 10 or 15 lines of code that'll give us basic functionality for browsing web pages, including clicking on hyperlinks. So so we'll get into that stuff next week. That'll be week 8. Service learning project deadlines are coming up soon. Somebody mentioned that in Discord, so dust that off if it's been a while. Don't get surprised by the coming deadlines for your formal report. Other than that, good luck finishing up PA4. Office hours tomorrow morning, 7:30 to 8:30 if you want last minute help. If I don't see you then, have a fantastic weekend, and I will see everybody on Tuesday. All right, take care.
I got a quick question about the SLP format.
Sure.
We're not uploading the project, we're uploading
the report.
Okay, and the report's not a one-page report like it was last time. Right?
No, the report's like, 20 or 30 or 50 pages, however long it takes, but it's all the details about your project.
Okay.
And that can include code or, maybe links to Git repos or things like that. But, block diagrams, schematics, all of the discussion of it, and so on and so forth.
So if you did like a game, maybe like the scripts you wrote, some of those in there.
Yeah, and you can also talk about, things that happened along the development. If you started, one path and then switched, you can talk about that in there. And issues and plans for the future if you're going to continue this, and things that you learned, and whatever else can go in there. It's sort of the whole synopsis.
If you switch from a 3D game to a 2D game.
Yeah.
Alright. Sounds good. Alright, awesome. Thank you.
Alright, cool. Have a good one.
Have a good one.
Thanks. Bye.